So next we will explore about the topic like symbolic artificial intelligence. It is rule-based intelligence. One of the earliest and most influential approaches to the artificial intelligence is known as a symbolic AI. It is also called as a rule-based AI or good old-fashioned AI. So this approach is based on the idea that human intelligence can be modeled using the symbols, logic, and explicit rules. So the main core idea of a symbolic AI is about so knowledge can be explicitly represented. Then the reasoning can be performed using the logical rules. Then the intelligence is a result of the symbol manipulation. So instead of learning from the data, the symbolic AI systems follow the predefined rules created by the humans. In symbolic AI, the real world fact are represented as the symbols. Example, so we'll consider this simple example, human, okay, then mortal. So here the human represents a Socrates and mortal represents a human. Then the rules describe the relationship between the symbols. So the rules are like if human of x, which is equivalent to the mortal of x. Using this logical inference, the system concludes so mortal Socrates. So this type of reasoning is similar to the mathematical or logical proof. So the idea here is a simple one. It represents the knowledge using the symbols and it uses rules and logic to reason with those symbols. For example, consider the following rules. The rule 1 is if it is raining, then the ground is wet. And rule 2 is it is raining. Okay. So using this logical reasoning, the system concludes therefore the ground is wet. So this is similar to how the humans solve the textbook logic problems. Okay. So next we will move into the rule-based reasoning. The symbolic AI system operate using if-then rules. Example is see here if fever and cough, then possible flu. Okay. Then similarly, if chest pain and shortness of breath, then possible heart problem. Okay. So the system applies these rules step by step to reach the conclusion. So this process is called the inference. Okay. So the main applications of this kind of the rule-based systems are expert system. Okay. So the most successful applications of symbolic AI was the expert system. The expert system consists of knowledge base. Okay. So knowledge base is about the fact and rules from the human expert. Then second one is inference engine. So this kind of the inference engines applies the rules to derive the conclusions. So next we'll see the example for this expert system. So the medical expert system assists the doctor by suggesting the diagnosis based on the symptoms. Similarly, so we can apply this kind of the rule-based system for industry applications also. The industrial expert system detect the faults in the machinery. Such systems performed well in narrow, well-defined domains. So next we will see about the advantages of symbolic AI. The symbolic AI has several strengths. So the few strengths only listed here. The first one is decisions are transparent and explainable, and second one is easy to understand why conclusions was reached. Then effective in the domains with the clear rules and logic. For example, a legal reasoning system can explain which laws and rules were applied to reach the decisions. So next we'll see about the limitations of symbolic AI. Despite its success, the symbolic AI has some major limitations. So the first one is like, so this kind of symbolic AI cannot handle the uncertainty well and difficult to scale to real world complexity and does not learn automatically from the experience and it requires extensive manual rule creations. So next we'll see about intelligent agent. Okay. So what is intelligent agent? In modern artificial intelligence, we often describe the intelligent systems using the concept of intelligent agent. So this provides a simple and unified way to understand how the AI system behave. So the first we'll see about what is intelligent agent. So intelligent agent is an entity so that perceives its environment through the sensor. It acts upon the environment using the actuators and it chooses actions that help in achieve the goal. In other words, the intelligent agent continuously so first will sense the environment and decide what action should be taken. Then finally it will act on the environment. So next we'll see about how the intelligent agent work inside. An agent internal workings involve the agent program that run on the computing device and process the data comes from the environment through its architectures. Let's discuss how an agent works from the inside using the program and architecture. So the first we'll see about the agent architecture. So the first component of architecture is environment. Environment is the area around the agent that it interacts with. An environment can be anything like the physical space, a room or a virtual space like a game world or the internet. Then second component is a sensor. Sensors are the tools that the AI agent uses to perceive their environment. So they can be any physical like cameras, microphones, temperature sensor or the software sensor that read the data from the files. Then third one is actuators. Activators are the tools that the AI agent uses to interact with their environment through some actions. They can be any physical activators like wheels, motors, robotic hands, or computer screens, or they can be software activators that send the messages. Then fourth case is effectors. Effectors take the instructions from the decision making mechanism and it translates them into the actions, and these actions are performed through the activators. So next we will see about the program or decision making mechanism. So this is a brain of the artificial intelligence agent. So this mechanism processes the informations that is received through the sensor and makes the decisions through the data using the programs. Let's understand how the agent's program execute the operations. So the decision making mechanisms often referred to as the agent program process the information from the sensor and making the decisions based on that data. The program takes a current percept as the input and generate the actions for the activators. So it embodies the agent functions which maps the percept to actions based on the agent's goals and objectives. So various types of agent programs exist such as simple reflex agents, model-based reflex agents, goal-based agents, and utility-based agents. So these programs differ in how they process the percept and generate the actions depending on the agent design and task requirements. So next we will move into the type of agent. So here we have various type of agents has been listed. First one is a simple reflex agents. Simple reflex agents act based solely on the current perceptions using condition action rules. These agents respond directly to stimuli without considering the past experience or potential future states. They operate on basic if then logic. If a specific condition is detected and execute the corresponding actions. The main key features of simplex reflexive agents are so no memory of past states, no model of how the world works, and purely reactive behavior. Functions best in fully observable environments. For example, the traffic light control system that changes the signals based on fixed timing. Second, we'll move into the next agent.